Hello, in this video we'll be looking at what happens when you combine vectors. Let's say we have an object there, okay, and it feels, let's draw it on the ground, and let's say it is being pulled in this direction by a force of, say, 10 newtons, and it's being pulled in this direction here with a force of 15 newtons. So what resultant force does it feel? What you can actually do is you can replace those two vectors with one vector, and you could do this by scale drawing. Now what you'll see is you can actually add the vectors to each other, so it's effectively like going along there to there and then up to there, okay, and then if you draw that along to there, so it's the same as going 10 along there, then 15 in that direction, you'll see the resultant force is in fact that one there, and we'll call that R. So in fact those two vectors could be completely replaced by the resultant vector R. And if we were to define the angle to the horizontal, say for instance that angle there being, I don't know, say 40 degrees, we can, by scale drawing, by scaling that as 10 centimeters and that as 15 centimeters, we can calculate, we can draw and measure the length of R, whatever that be, and also what angle, let's call that theta, to the horizontal is, and that is combining vectors. Or we could use mathematics, possibly the sine or cos rules, but scale drawings would be better. Okay. Now, often in the case with vectors is that vectors are given at right angles to each other. It's a very, very useful idea. It makes the mathematics a bit much easier. So, for instance, let's have a game. Here's the floor and an object, and this time we'll apply a force of 4 newtons to this horizontal and 3 newtons to the vertical. And again, it's the idea of we can draw, so 4 then up 3, we can draw in this case it's a rectangle, but that being a subset of what we had before, which was a parallelogram. Now we then draw in the resultant vector here, okay, and in this case now we can find out the size of the vector and its direction with relatively simple mathematics. First of all, we can use Pythagoras. So we find that the magnitude of the vector r is r squared is equal, that's the magnitude of it, r squared equals 3 squared plus 4 squared, 16 plus 9, that equals 25. And very conveniently, we find the magnitude of the vector r is in fact 5 newtons. That's the magnitude is 5 newtons. And what is the angle theta there to the horizontal, thus defining the vector? We'll see, we can think about it as simple trick. Let's draw a simple triangle. That's the angle theta. We have the opposite there, the adjacent and the hypotenuse. And from the rules, you may remember the one rule is that tan theta is equal to opposite over adjacent. So in our case, tan of theta we want is actually opposite. Well, that would be 3 there. 3 divided adjacent 4, so tan theta equals 3 over 4. Okay, so therefore that would imply that theta is equal tan to the minus 1 of 3 over 4, and then your calculators you'd put it as 0.75 perhaps, or just leave the fraction. Theta equals tan minus 1 3/4, 0.75, and that, as I calculated earlier, is equal to one decimal place 36.9 degrees. So thus we have defined our vector that those two can replace by an r the vector r is equal to the force of 5 newtons at 36.9 degrees to the horizontal being defined in our diagram.